Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of reflection, and it is a very simple idea. Basically, you are going to have some sort of a mirror. And this mirror is situated halfway between the point and its image. So, as an example, if you introduce a negative sign next to fx, so here fx is actually y. And therefore, if you have a negative sign next to y or next to fx, the graph will be reflected through x-axis. All right. And if you introduce the negative sign next to x, so this is right next to x, then the graph will have the line of reflection on y-axis. So this is a sort of reverse idea here. Negative y and the line of reflection is going to be on x-axis. So here we have negative x and the line of reflection is going to be on y-axis. Now let's talk about example. Okay, example of reflection. So let's say that this is the graph, the original graph given here, and this graph is described by this function. So this is an exponential function. Now let's say that you are then asked to sketch the look of a new function, which is gx, and gx is simply comes from introducing the negative sign next to fx. So this is equal to having negative 2 to the power of x. So how do we sketch the graph of gx? Well, in a normal circumstance, what if you don't know how the graph looks like? The natural step to do is, of course, to substitute the values of the value of x here with any number, any simple number that can be calculated straight away. So you are going to substitute values or numbers into x, and then you'll be able to get point y. So you'll be able to get all the points here in order to sketch a smooth curve. Now, instead of doing that, we are going to save so much time by considering the rule given here. So we know that if we have negative fx, then we are going to have this graph here reflected on x-axis. So you're going to have the original graph reflected on x-axis. So for example, if this is the first point that you have, then this point will be reflected to this point. Okay, you can see that the distance from this to the line of reflection is the same for this one and this one. So you have the same distance from point to the line of reflection and from image to the line of reflection. So next, you can also get, for example, this point here. You will know that this will be reflected to somewhere here. Okay, for example, this one will be reflected to this point. This point over here will be reflected to this position. So based on this, you have quickly managed to get some of the points here where you can actually draw a smooth curve. So this is a quick way to find the points to sketch the graph of gx. Okay, using the idea or using the rule given here. Now let's move on to the next example. So let's say that this is a function. So this is the look of the function, the same function, exponential function 2 to the power of x. Now let's say that you are asked to sketch the new function, which is hx, and hx is equal to f. You are introducing the negative sign right next to x, and this can be written as 2 instead of writing x, you will have negative x. Okay, so instead of x, you will replace x with negative x. And we, like I said before, instead of trying to get all the points by substituting the values, we can quickly obtain the points for plotting by using the rule given here, where we know that if the negative sign is introduced right next to this function, this already available function, we know that the graph here is going to be reflected on this y-axis. So this is the line of reflection that we have over here. And so, for example, if I have this point here will have its image situated somewhere here, where the distance is the same from point to the line of reflection and from image to the line of reflection here. And for this one, okay, this is the original point, original function. This will then be reflected somewhere here with the same distance. For example, this one, it will be reflected to this point, and because of that, you manage to get 1 point, the second point, the third point, and following the same manner, you'll be able to get some of the points needed in order for you to draw a smooth curve. So this is the new graph, and this is how it looks like. Okay, so this is how it looks like. So this is the graph for hx. Okay, so let's move on to the next example here. Now, given this this graph, write an equation that describes this graph basically. So we're going to start off with trying to recall the basic function. Okay, so I'm sure that you remember, if you have y is equal to absolute value of x, then the graph will be looking something like, will look like this. Okay, this is x, this is y, so it has a V shape, looks like this. And I'm sure you can see there is a similarity between this graph and the one that is given here. So we just need to do some sort of transformation in order to get this look. In order to get this look, we need to do some sort of transformation for this basic graph that we have here. So first of all, so you can imagine we can have this graph somewhere here. Okay, so this is the graph somewhere here, and this graph is described by this one, which is y is equal to absolute value of x. Now imagine that this graph is moved, this vertex here is moved towards this point. So the next step is to move this graph to this point here. So this is going to be introducing something right next to x. Okay, so we're going to introduce negative. So this one is, the coordinate is 1, 2, 3, 4. So we're going to introduce negative 4. So by doing that, this graph here will be moved 4 units to the left. Okay, so now the position of this graph is going to be at this point. Okay, so this is the position of the new graph. So next, we know that this looks like some kind of reflection, and what we can do is, before we do the reflection, we should move the graph a few units up so that the distance is sort of match here between the line of reflection. So now I'm going to move the graph how many units? So this is 1, 2, 3. So we're going to move the graph 1, 2, 3 units up so that the graph is situated somewhere here. Okay, so in order to move the graph 3 units up, we're going to introduce y is equal to x minus 4, and we're going to introduce plus 3. So we introduce plus 3 outside the function fx. Okay, so it becomes the absolute value of x minus 4 plus 3. So now the graph is situated somewhere here, where you can see that the distance of this point to this line is equal with respect to this point and the line of x-axis. And we can see clearly that this is a case of reflection. So in order to say that it is reflected on x-axis, what we can do is we can consider introducing the negative sign outside the whole function of fx. Okay, so fourth step is we're going to introduce the negative sign outside this function here, the whole function. So it will be absolute value of x, sorry, not plus, minus. So that is going to be minus plus 3. Okay, so if you want, you can simplify that. You can take out the bracket if you want. You can have negative 3 minus the absolute value of x minus 4. So there you go. That is the equation for this graph given here. Alright, that's all for now. Thank you very much for watching.